After the inception phase, we begin the elaboration phase. Notice that we're still capturing requirements. We're still doing some business modeling. We're doing substantial analysis and design now. Notice that in this approach, analysis and design are mixed together. There is not this clear demarcation between what business analysts do and what programmers do. There's some mixing of it together, realizing, though, that there are still those different roles involved. We begin to actually write some code in elaboration, even though we're still capturing requirements and doing our business modeling. In other words, we have a pretty good idea about what some of the code will be that will be needed. And so we can begin to write some parts of the application. Object-oriented programming languages help make this possible. I don't want to go into this because this is a class intended for managers, but object-oriented programming languages are modular in nature, and you can begin to write some of the classes that you know will be needed, some of the modules, if you will, even though you still have not finalized your business models and your requirements. And look here, we even begin to test some code in the iterations within the elaboration phase. One of the benefits of this is if you have a team of programmers, this approach helps keep them busy. You know, programmers earn good salaries, and if they're on payroll and not doing anything, if they're on payroll, perhaps it's better that they're doing something. But it takes a good manager to make sure that they're doing the right thing and not running too far ahead of where they should be in order to avoid a situation in which they write code that was not really necessary to be written. Then the third phase is construction. Construction consists primarily of writing code and testing code. But we're still doing some analysis and design. Business modeling is pretty much behind us now during construction. And if somebody ran in and said, "Oh, I forgot, there's another feature that I want you to add," under this iterative incremental model, it would probably be possible to say, yes, we think we can accommodate that request, as opposed to under the waterfall model in which you would say, forget it. If you need that feature, we can talk about that after we've deployed what you told me 3 months ago you needed. So this is more, in a way, more realistic because needs change. And software development projects can last for many months. And then after the construction phase is complete, comes a phase called transition. And this means actually moving the new application into service. The primary activity here is deployment. There's still some testing going on. There may even still be some writing of code going on. But primarily in this phase, we're focused on deployment of the application to the employees or the clients, whoever this is for. Notice that deployment begins, according to this illustration, very near the end of construction. I think that's generally called beta. The beta version may be released even though it's still incomplete and maybe a little buggy. It's sometimes okay to do a limited deployment of the new product, even though it is not yet complete. Again, a project manager is a very valuable person, somebody who knows what is okay and what isn't okay. The spirit of the iterative incremental model is that our team can do more than one thing at a time. We can usually accommodate change requests during the development. We test our code early and often. This is important. You don't write all your code and then start to test it. You write and test, write and test. And this mitigates some of the risk. There are programmers who specialize in testing. They get up every morning not to write code, but to test code that others have written, to try to break it, if you will. And these aren't bad people. They're people whose job is to make sure that others didn't overlook something. If you identify a problem sooner, it can be corrected for relatively little cost. But if bugs and problems don't go detected until late in the process or until even after deployment, they can become far more costly to remedy. And we are not counting on a miracle at the end, which might sometimes be part of the plan under waterfall. We have our act together. We have our ducks in a row, whatever metaphor works. Maybe not ducks in a row. But we have anticipated the hardest, most risky aspects of the entire project, and we know how we're going to solve them. We don't just kind of let them accumulate with the idea that we're going to address those things later. So what is analysis? Analysis is understanding the organization's need. An analyst is not necessarily a programmer, although it's probably good if he or she has some understanding of programming. An analyst thinks in terms of business processes. How do we do what we do? Design is more technical. Design takes the specifications created by analysts and begins to plan, and does plan, how the solution will be designed. Implementation, as I said a few minutes ago, is actually creating the source code, using tools that programmers use. And deployment is delivering the new application to the people who will use it. So, why is software development so hard? It's hard because it's complicated. Waterfall is not a satisfactory project management approach today. It's a good beginning. It's a good way to begin to understand what the challenges are. But with object-oriented modern programming languages, and with the needs of organizations changing as rapidly as they are, and with the complexity of modern projects, waterfall just is not often a satisfactory approach unless the project is relatively simple. There are so many opportunities for misunderstandings.